Alright, so my name is Lincoln, and I'm going to be talking about modeling susceptibility of Adirondack lakes to acidification. This deals with sort of making a model to try to predict and select which lakes are most at risk for acidification and have the least ability to resist changes due to acidification. So now I'll get started. To sort of set the baseline for this, acidic deposition or acid rain has been around for a long time. It started with industrialization in the mid-19th century, when factories really started popping up and our economy moved from a more agricultural base to a more production and industrial based economy. This diagram on the right is pretty good in explaining what acid rain or acidic deposition is. You have smokestacks here that are releasing two harmful pollutants, one being sulfur dioxide and the other being nitrogen oxides. Those oxides can come in many forms. Once they get up into the atmosphere, they react with water vapor and water in general to form acidic components such as sulfuric acid and nitric acid right here. And then once that's formed, it can collect and get heavy in the atmosphere, and that's when it drops down to the terrestrial environment. That could be either in dry deposition or wet deposition. And here we're mainly going to focus on wet deposition. Once it gets down into that terrestrial environment, that's when a lot of problems are created for vegetation, for water bodies, for soil, and that sort of stuff. Another way that some of these harmful pollutants can get in the air is vehicles, automotive vehicles, and they mostly are responsible for nitrogen oxides being released into the atmosphere. Another piece of important history regarding to air pollution in general, but more specifically acidic deposition, is the Clean Air Act. So the Clean Air Act of 1970 was sort of a follow-up to the 1967 Air Quality Act, which authorized the enforcement of procedures for minimizing air pollution. It was really a landmark set of laws and policy that really kind of was part of that big environmental revolution through the United States government. The most important amendment in terms of addressing acid rain, though, came in the 1990 amendment to the Clean Air Act, which created programs for acidic deposition control. And that's really where we started to see changes in the amount of sulfur oxides and nitrogen oxides being added to the environment. And we saw drastic changes in the amount of acid rain occurring. So we talked about the causes a little bit there. Like I said, industrial and automotive emissions are the main causes of acid rain, and it can have really horrible effects. It can completely kill populations of fish and other aquatic organisms. Certain fish like trout species and salmon species are very, very, very particular in what pH level the water that they live in can be, and it can kill their eggs once they've been laid. It can kill young minnows in the early life stages, and it can even wreak havoc on, the bodies of adult fish. So that's one big problem. Another is a loss of buffer material. Buffer material is certain ions in water, in soil, or in bedrock or rocks in general that can react with acidic components and neutralize them, so that the entity, whether it be a lake or a river or a forest, can resist changes in acidity and pH. That's going to be one of the main parts of this model, is the buffering capacity of certain materials. And then it can also have the effect of just changing water chemistry in general. When pH decreases, you can see changes in the amount of dissolved oxygen or dissolved carbon inside of the water, changes in heavy metal concentrations, which can also in turn affect fish. So it's really a big problem. And luckily, since our government created the Clean Air Act and added the amendment to control acidic deposition, we've seen decreases in it, but it's not a completely solved problem. And then just some more factors that determine an area's susceptibility is annual precipitation. The more rain you get, the more likely that rain is going to have acidic components. The bedrock geology, your limestones, which are rich in calcium, are going to be more likely to resist changes in acidity than, your igneous bedrock that has very little calcium or magnesium in it to resist the changes. Your soil, same thing. Elevation, your slope aspect and your slope ratio, where your water is collecting when it falls to the terrestrial environment is important, and then vegetation. So the objective of this study was to develop a model that can highlight which lake watersheds are most susceptible to acidification using precipitation and bedrock data. And this is just a map of New York State, and the study area is highlighted here as the Adirondack region. This was done taking a normal precipitation map from New York State and then a land class map from the Adirondack Park Agency. All of the data for this project was taken from the clearinghouse, the USGS clearinghouse. And I'll kind of run you through it. So the climate is mainly to do with precipitation, and that's this map down here. It started as a shape file, a feature file with precipitation contour. So between each line represents a different level of precipitation in inches. The geology is a feature class file that has, each of these little polylines or polygons correlate to a different type of rock type. The watershed just kind of gives an outline of every basin in New York State, and hydrography is a map of all of the major water bodies in New York State, and you can tell that there's a lot of it. And then the land class is what I talked about, just using it to set my study area. So the first part of my project was kind of getting all of these really large New York State files down to a little bit more manageable size. So I clipped them all using the land class model, and that sort of allowed me to better understand what I was working with. Specifically with the hydrography and the water bodies, I found that there were far too many lakes for me to analyze if I were to just look at all of them. So I selected by attribute for water bodies that had a surface area greater than 5 square kilometers. And then I converted all of my newly clipped features to raster files. Once that was done, I reclassified the geology and precipitation rasters so that they could kind of be ranked based off of, for precipitation, it was based off of